justification is generally going to be given. Just verify that that's the case. All right. The next thing that I tend to encourage you to do is look to interpret any given information that is worded. So if I label what I have here, so angle GFH, this angle right here, is equal to angle GHF, this angle right here. So those are the only two measurements that we can label on here. All right. The next relationship here is that angle GFH is equal, or the measure of angle GFH is equal to the measure of angle GHF. Okay. What allows me to go from stating that the angles are congruent to their measures are the same? Okay. This is always going to be based on this symbol. Okay. The symbol of congruence can be converted into a measurable or a measure that can be added, subtracted, multiplied, divided by using definition of congruence. Okay. And it can work in either direction. So definition of congruence can also allow you to say that if two measures are equal, then the angles or the segments are congruent. So definition of congruence allows you to say equality of measures is the same as congruence of elements in either direction. And all this does is it allows us now to work with these as measurements rather than as the physical elements of angles. Okay, so if we look at the next statement, the next statement says that angle EFG plus angle FGH, so EFG plus FGH is equal to 180 degrees. Well, what kind of angles are those? These are adjacent angles that form, they are straight angles, adjacent angles that form a straight line. What do we call those? This is an example of a linear pair. Remember, adjacent angles that intersect or that are formed when lines intersect are a linear pair. And a linear pair, by definition, are going to be supplementary. They add up to 180 degrees. And so what we will use for this justification is, you don't have to write that whole relationship out, that a linear pair add up to 180 degrees. You just state definition of linear pair will give you that statement. All right, so what would then allow you to create this next statement, statement 4? So you see statement 4 is almost identical to statement 3. The only difference is that we replace this measure with angle GHF. What allows us to replace one thing with its equivalent? Substitution, right? So all we did is we replaced, in statement 3, we replaced GFH, measure of angle GFH, with its equivalent, which is angle GHF from statement 2. And so that's substitution. Anytime we use substitution, it's always good to go back and just verify that it's not transitive property. So to test that, we look at the left and right side of our equations. Do we have 180 degrees somewhere earlier in our proof? We do. Do we have angle EFG plus angle GHF somewhere earlier in our proof? No, there's no place where that exists earlier, right? So it can't be transitive property. So this is an example of only substitution. And therefore, we can go to our last statement, which is angle EFG and angle GHF are supplementary. And the way that we can bring in words to proofs is by definitions. Okay? And so if you start with a word in your given and you interpret that, that's definition of the word. If you take a relationship like we are right here in statement 4, and we convert that into a word or interpret that back into a word, it still is definition of that word. So definition of supplementary, I'll probably abbreviate it in this manner when you're working online. Okay, and so this would be your answer for that last step. All right, so the types of properties that we're going to be using in our proofs now with the angles include definition of congruence, like you see and like you saw in this segments. Definition of linear pair, vertical angles. I'll talk about that as well. Remember, vertical angles are formed. They're the non-adjacent angles when two lines intersect and they are equal to each other. Okay, that relationship will be used. Definition of complementary, definition of supplementary, definition of perpendicular. I can't remember, when we talked about perpendicular, it didn't appear like specifically in the notes. I can't remember if we talked about it or not, but perpendicular was part of the if and only if biconditional statements, and it was that two lines are perpendicular if and only if they meet at two right angles or intersect at a right angle, and that is the definition of perpendicular. It means that the angles that are formed are going to be 90-degree angles. And so those are the types of relationships that you will see involving angles here. All right, so let's take a look at this next example. We're gonna walk through this one here together again. Okay, so here's your given information. We start off by just confirming, is the first statement really our given? It is. Okay, now, the way that I encourage you to work through these is if your given statement has a word, interpret that word. So if I go in here and I look that ray CW bisects angle ACX. Well, here's ACX is this whole angle. So if CW bisects that, it means that each of these is going to be cut into half, or cut into half of that whole. Okay, so the marking there shows my interpretation of the word bisect. So what I want to do now is I want to go in and see, can I find that relationship in my proof? Okay, it's not statement 2, but what about statement 3? Statement 3 says angle 1 is equal to or congruent to, or measure of angle 1 is equal to measure of angle 2. That is the relationship I just labeled. And so I got that by using the definition of what word? Bisect. It always, if you're using a definition, it has to be a word that actually appears in the proof. So that's the first thing I would do. Even though it's not the second step, I would interpret the given information. And then you can start to kind of work from there. Okay, angle 1 and angle 4, now it's introducing the end state elements here. Angle 1 and angle 4 are equal. If I label that relationship, what allows me to make that claim? Not linear pair, but the other one. They are vertical angles, right? So here's two angles that are vertical angles, and we know that vertical angles are equal. And the way that we're going to justify that, we're just going to put VA. VA is will be used to abbreviate that these are vertical angles, therefore they have equal measures. Right, next we get angle 2 is equal to angle 4. So now if I look at this up here, I see that angle 2 is equal to angle 4. And I can probably see from just the markings up here, if 4 is equal to 1 and 2 is equal to 1, then it would make sense that 4 and 2 are equal to each other. But let's go through and test that. So that's a substitution. But let's see if it's transitive property as well. So look to see, can you find angle 2 earlier in your proof? You do. Can you find angle 4 earlier in your proof? You can. Are those both set equal to the exact same thing? And when you look, angle 2 is equal to measure of angle 1. Angle 4 is equal to measure of angle 1. When you compare those, I said the exact same thing. Therefore, if two things are equal to the same thing, they're equal to each other. That is transitive property. Okay, now, it's also substitution, right? Really what you could do is you could say, we take statement 2 right here, we write it, leave angle 4 on the right side, and we replace angle 2 or angle 1 with its equivalent to angle 2. So this is also substitution, but when we look, it's also based on the property of the transitive property as well. So we include both. All right, the final example that I want to talk through looks like the following. Okay, so once again, I'm going to talk through this because this has some new elements and some new ways that justifications for statements. And I just want to make sure we'll kind of go through them here together. So statement 1 is this statement 1 repeating our given? It is. So we justify that by that was what was given. Now notice there is a symbol in this statement. Okay? I encourage you as a first step is if you have a word or a symbol in your given, go ahead and interpret that, find where that is in your proof, and label it. So the fact that AB here is perpendicular to XY, that means that it forms right angles. That's what being perpendicular means. So that means that all 4 of those angles are right angles, okay, or 90 degrees. You can use either of them. So definition of perpendicular can either be give you angle is a right angle, or it can give you the measure of the angle, and I'll put a question mark here because that'll be whatever, but the measure of the angle is 90 degrees. So you can use definition of perpendicular either as a word or as an equation. So we're going to look for either of those in this proof. Do we have anywhere that angle ACX, BCX, BCY, or ACY is equal to 90 degrees? Yeah. And so right there is the definition of perpendicular. Okay, so I tend to interpret my givens and find where those are first, and then I'll go back in and complete the rest of the proof. Okay, so let's look at statement 2. Statement 2 has the pattern of 2 things added together to equal one thing. Okay, we saw that with the segment addition, that if we have 2 things equals, or the sum or difference of 2 things equals one thing, it's generally segment addition. If it winds up not being segment addition, then it's likely going to be some kind of substitution. Okay, when we look here, it's the same idea. We have 2 things added together to equal one thing. If those 2 things happen to be adjacent to each other, here angle 1 plus angle 2 is equal to angle ACX, this whole thing. So what we see is that the sum of the parts is equal to the whole. That is angle addition, right? So it's like segment addition, but with angles, the sum of the parts is equal to the whole. Remember, angle addition can either be the same thing, measure of angle A is equal to measure of angle B plus measure of angle C, or it could be measure of angle B is equal to measure of angle A minus measure of angle C, or measure of angle C is equal to measure of angle A minus measure of angle B. So those are the alternate forms, right? But this is all angle addition. Angle subtraction will be a distractor. It's never going to be the correct answer. It's only a distractor, just like segment subtraction. Okay? And so this would have to be angle addition for this problem. Right? Once we continue to work through our problem, we see angle 1 is equal to angle 4. Again, it might be substitution, might be transitive property. It might be something based on the graph. Let's look at the graph here. When we look at the graph, we see angle 1 and angle 4. Once again, what kind of angles are those? These are opposite angles formed when lines intersect, so those are vertical angles. Vertical angles are equal. Okay, so we see that relationship. And so our final step is angle 2 plus angle 4, or the final statement, angle 2 plus angle 4 is equal to 90 degrees. And so we have 2 things added together to equal a third thing. When we look at these, the 2 and the 4, they're not adjacent to each other. The 90 degrees doesn't exist except for in statement 3. And so more than likely what we're doing is we're taking the statement from step 2 and we're rebuilding it by substituting in equivalent values. And we have our angle 2 stays where it is. Angle 1, which we see is equivalent to angle 4, so we can substitute that in. And then angle ACX we see is equal to 90 degrees, so we can substitute that in. And so all we're doing in statement 5 is we're taking the sort of the structure of statement 2, we're replacing 2 things with their equivalents. And when you replace something with the equivalents, it's substitution. Now, let's double check and make sure it's not transitive property. Okay, when you look at this, 90 degrees does appear earlier in our proof, but angle 2 plus angle 4 does not. There's no place where that appears, so there's no chance that this is transitive property. And so we justify it as substitution only.